Hello everyone, welcome to my presentation. Today I'm going to talk about the CFD for indoor environment assessment. This is my outline. First, I will introduce the background information of the topic and the CFD. The second, I will going to introduce the review of the previous study. Then I will going to talk about the summary of the weakness of study. Finally, I will introduce the potential and the solution of the problem. In modern world, with development of computer technology and requirement from the society, computer simulation raise human attention to access in living environment. In recent decades, the world economy has experienced a huge rise. However, human living environment is not as better as in the past. To satisfy the requirement from the resident about the quality of life, CFD or other fluid simulation technology which can be used to access the living environment plays an important role to get the design of fluid or evaluated the quality of building. Based on the computational fluid dynamic, the simulation technology can be used to predict the indoor heat comfort, evaluate the performance of air conditioner and ventilation system. Also, it can be used to detect the indoor pollution diffusion. Let's see some previous study. Genoa with France evaluated the indoor pollution with CFD method. In this simulation, they researched the impact to simulation accuracy with different boundary conditions of temperature and velocity around the human occupants. There are two groups of the experiment data were used to simulate and test the accuracy. Three boundary conditions were found to be important in simulation: range of the pollution area, heat flux with the convection and radiation, shape and size of the human body. These assumptions were built up from the appropriate numerical parameter, such as grid cell distribution that minimize the numerical divergence and capture the turbulence phenomenon in physical field. They also found that they can use the point source as a small area source, and the region size must be larger than real size of point source in physical field. This amplification has numerical advantages that it helps to accelerate the convergence process, because this method can help the calculation from the decreasing number of requirement volume control cells. This kind of method should be implemented carefully to avoid the accuracy issue. If those points are fixed at once the predict location within physical field, this amplification is practical and the accuracy can be maintained even the initial size extends for many times. However, if those points are active and located at a complicated and unpredictable physical field, the inaccuracy can be introduced into the system. Zhang with France accessed the indoor heat comfort with CFD technology. In this study, they set the indoor arrangement and introduced the traditional Navier-Stokes functions with new terms. The first is continuous equation. The second is momentum equation. With following is the turbulent momentum equation. Finally is the kinematic energy turbulent equation. Turbulence kinematic energy dissipation rate equation. Then following is the term of the turbulence energy equation. Finally is the turbulence viscosity equation. In above equation, G represents the turbulence kinematic energies generation which comes from the main values of the velocity gradient. PR denotes the turbulence coefficient of the energy. In standard fluid field, normally the PR default value is 0.85. Mu A represents the dynamic viscosity coefficient and alpha is the direction indicator. In three-dimensional space, X is 1, Y is 2, Z is 3. Cp represents the specific heat in fluid field. K represents the kinematic energy of turbulence. Epsilon denotes the displacement rate of the turbulence. The rho represents the current density of fluid. Fp is pressure means value in time domain. Qt represents the heat source intensity, where T is current temperature in fluid field. T0 represents the operating temperature. B denotes the thermal enlargement coefficient. C1 and C2 and C mu are constant value at the 1.44, 1.92 and 0.09 respectively. Delta K and delta epsilon are Pinot number of turbulence for kinematic energies of turbulent and the displacement rate of turbulent respectively, and the value are 1 and 3. C3 has no exact value. It can be calculated by the following equations: C3, tan Rp, and Un, where tan is the hyperbolic tangent, Up means flow component velocity parallel to the gravity directions, and Un means flow component viscosity normal to the gravity direction. Ning with friends access the indoor carbon dioxide concentration and flow with CFD method. In this simulation, the human exhalation was considered as a new source of system. Therefore, they added the Navier-Stokes function in energy form in evaluation to satisfy the energy conservation. And here is the Navier-Stokes equations in energy form, where E represents the whole energies, the ρ denotes the density of fluid, Fp denotes the force that caused by the dynamic pressure, and the Ke represents the coefficient of conductivity. The H means the value of the infusivity. The mu represents the velocity of flow. The T represents the temperature of flow air. The tau E represents the effective shear stress in flow air. This study used the energy equations to evaluate the momentum of airflow. Thermal condition is used as a term to share the energy with momentum. In this case, another key term was ignored in the simulation. Carbon dioxide flow with air is the multiphase flow. There is a thin layer between carbon dioxide and air. This layer can be considered as a free surface boundary, and the surface tension should be added in this condition. So, what is the weakness of the previous study? As we know, previous studies have already searched many approximation methods to approach the real flow, such as continuous equations to evaluate the density of the flow material, using Navier-Stokes equations to evaluate the momentum and energy of air, and analysis the boundary layer to search the performance of heat transfer. However, those studies did not search the surface tension on boundary layer between two different layers. Also, they did not search the heat conduction with fluid flow that it can have influence to the momentum. In addition, the time consumption is another issue in simulation. Efficiency with disturbed energy failure to catch up the efficiency requirement. So my research will focus on the following part. The first is added the surface tension equation into the evaluation procedure. The second is find out the heat energy equation and added it into the Navier-Stokes functions in energy form. Combine heat flux and flow together, using new computer platform to accelerate the simulation. From basic concept, the CFD method spatially discretizes the continuous media into cells, and the field variable normally take the information about the pressure, density, viscosity, velocity. In this simulation, the field variables also take the temperature element. All those field variables will be expressed with the finite discretized point into the physical field. The platform of simulation based on the code normally are the MATLAB and Python, etc. Following the field variable function sets will be rewritten based on the finite difference method into spatial formatting to corresponding to the physical model of CFD. Finally, the value of physical variables can be evaluated from the equation solving. This is the models of my simulation. In this room model, two openings are door and window, which can be considered as a source of system. Television, human body, and other layouts will be thermal exchange with flow air. The grid that close to the object are ununiformed to capture the shape of the indoor layout. And for the equations, the first is the continuous equation, then is the Navier-Stokes equation in momentum form, and the Navier-Stokes equation in energy form. Energy equation of surface tension, and this is the coefficient of H. In surface tension equation, Q is the surface tension, pi is the ratio of the circle, R represents the radius, and R multiplied by cosine theta denotes the component of force along horizontal direction. The G represents the gravity, and the ρ is the density of the fluid thermal. equation of the thermal and momentum energy. In thermal and momentum equations, the d phi and d tau denote the energy, entire energy change with time. The dk represents the heat transfer from surrounding to fluid. The phi denotes the heat generation from flow fraction, and qi represents the heat from the interaction of the fluid. To achieve this heat transfer, the thermal and momentum equation can be fitted into the flow chart to finish the value compensation. Also, surface tension equation can be modified and added to the Navier-Stokes equation. So that is all for my today. Thank you very much.